All right, let's talk code organization. So in a previous video, I mentioned the fact that we don't have classes in C++, and classes are great for organizing data and functions and methods that work on them. So just because we don't have the construct in the language to do that for us, that doesn't mean we can't organize our code with the same kind of idea. So I want to demonstrate how we can still kind of do the, shall we say, we could follow the spirit of object-oriented programming in C just by kind of grouping things together in our files and the way that we build things. We can also actually make a slight modification to the way we build our functions that makes that even more convincing, but we'll get into that later. For now, apparently I'm going to make my computer beep at me a lot. Okay, here we go. For now, let's talk about how we could do this. So in a C++ program, we would declare our classes in a .h file, and then we would put the source in a .cpp file. So obviously then the equivalent of that in C would be to declare our structs and our functions in the .h file, and then we can actually define the functions in a .c file. So I'm going to do that. I'm going to identify a few functions that a few activities I'd like to do on this data struct dog. Things I'd like to do with structures of that type, or with objects of that type. So one of the things I'd like to do is to be able to get a list of them from the user. So I'm going to declare a function. It will return void. I'm just going to call it getDogs. And this function will take in two arguments. The number of dogs, I'll do it this way, the num dogs that we're supposed to read in, as well as a pointer to a location where we're going to store those dogs. Okay, now again, I'm just going to declare the functions here. And another function I'd like is one that can print the dogs in such a list. Okay. Now, one of the things I want this program to do is to be able to, or wanting to do with dogs, is I might want to be able to sort them. So maybe I want to sort them by, we'll say by their age, for instance. So whichever dog is the oldest, or excuse me, the youngest, I want that to go first, and we'll go in ascending order up to the oldest. So in order for this to work, I need the ability to compare two dogs to decide which one precedes the other. And so to do this, I'm going to use a compare function with a very specific set of inputs and return value. And I didn't pick these were determined for me because I want to be able to use this method, or excuse me, this function compare in tandem with a library function called qsort or quicksort. And it will allow me to give it as an argument a function, or function pointer, that it can use to do the quicksort algorithm. So in order for this to work, then my compare function has to have a specific set of inputs and a specific return value. So it needs to take as arguments two const void pointers. And I'm just going to call them P1 and P2. This will become more clear in a moment what this will be used for, but for now I just want to declare that function. All right, so these are the functions that I would like to have available that I can use with the struct dog. So let's, if I can get my keyboard to work properly, we'll go ahead and save that. And now I'm going to need to create a .c file where I can actually implement these. So I will create a new tab, and I'll have to name it when I save it. I failed to give it a name. Go in insert mode. And the first thing I need to do is include dog.h because we're going to be dealing with that data type quite a bit. So one of the functions that I've already declared then was getDogs. And again, it took numDogs and pointer dogs as arguments. Now what I'm going to do in this function is I am just going to loop the number of times indicated by numDogs and on each loop iteration I'm going to tell the user to enter the name, age, and weight of a dog. Excuse me, of will actually be more explicit. We'll say dog, number, and we'll count them off as we go. Okay, now this format specifier %d, that's going to be populated with the value from our index I. And then we'll need to scanf. And so first we'll read in the name of the dog, as we said, and then we'll read in 2 floating point values for the age and weight. We need to give targets for each of those that we specified. So how are we going to do this? Well, we've got dogs, and this is a pointer then to what we're assuming is an array that was allocated somewhere else. We can find the one we're specifically trying to populate by using the index I again. And the name comes first, and the age, and then finally the weight. Now, if you've got a quick eye, you've noticed I've made a mistake, and it's a common mistake, so that's why I wanted to demonstrate it. You'll notice that age and weight are both floating point values. And so if I was to call this function scanf, it would complain that I have not provided addresses for these variables, and it needs those addresses so that it can actually write directly to those locations and change the value of dog's I.weight. So we need to provide then the ampersand in front of each of those. And just to reiterate this one more time, I don't need to do that with name because name itself is a char, as an array of char. So this is an address that's actually being sent into scanf. Okay, so this function should then read the appropriate number of dogs from the script from the user. It's always a good practice to test your code as you write it. Don't try to write too much. Oh, I failed to give it file name. Okay, let's try that again. I'm going to write it. We'll write it to dog.c. Okay. Now we need to modify our makefile a little bit at this point, since now there's an extra source file involved. So we'll open up our makefile, and I'm going to add a dependency for a rule called dog.o. And then I will create a rule called dog.o, which will need dog.h and dog.c. All right, and cxx, cxx flags, and we'll compile dog.c, and we'll stop with the .o file. Stop with the -c flag. Okay, so we'll write that. Oh, not quite finished. Okay, let's modify now our main program. And let's put this function to use. So we're including dog.h, so we know about the function. And we'll delete this line, it's just fluff now. We still need to allocate the appropriate space. We don't need this, that was just for demonstration purposes. So let's use our function. So it was called getDogs, and we will provide it then first the numDogs argument, and then the pointer to the array that we have allocated. Now if all goes well, this should ask us to put in the information for the number of dogs we specify at the command line. So we'll do a make. Let's see here, we've done something wrong. So get dogs says undefined symbol for architecture X. Oh, I know what's wrong. Let's go back. Okay, so if we go and look at our make file, we see that I have omitted something important. So we said that this rule depends on dog.o, but then I forgot to include dog.o in the command that actually compiles all this. So what happened is we made it as far as the linker, and then it said, I don't know anything about this symbol. Let's see. There it is, this symbol get dogs. It said undefined symbol get dogs. So that's what happens if we've declared a function but never actually define it. So we included the .h, so we had the declaration, but we didn't have the code from that dog.c file actually being included in our final product. That's why we had that problem. So now we should be fixed. Sure enough, that runs. So we'll do sort dogs, and we'll just be lazy and we'll say we just want to work with 2 dogs. So we'll work with a dog called Pepper. We'll say that she's 1.5 or 1.2 years old and weighs 10 pounds. All right, the second dog we will call Buster, and we'll say he's 1 year old and that he weighs, I don't know, 12 pounds. Okay, and it took that. We haven't done anything with it yet, but we did succeed, it appears, in getting that function to work and to read in that data. All right, let's go a little bit further. So we've created the function getDogs. Now we need printDogs and compare. All right. So printDogs was also a void function, meaning it does not return anything. Takes in numDogs as well as a pointer to dogs. And what does it do? Well, it's going to loop through the number of dogs as well. But in its case, instead of trying to read things in, we're just going to print things to the screen. So I'm going to want to print a string, which will be the name of the dog. And I don't know how big those are going to be yet, but it's pretty obvious that not all dog names are going to be the same length, and this can get kind of messy if we're jumping back and forth textually from left to right with dog names of different sizes. So for instance, if the dog's name is Sam, that's just 3 letters, and if the next dog is named Peppercorn, for instance, again, then that's a longer name, and so it's going to shift everything in the sentence to the right, and that looks kind of messy. So I'm going to just demonstrate again that we can do some pretty neat things with these formats as specifiers. And we can say, for instance, I want to left justify a string that is 10 characters wide. Okay? And so we'll say then this will be the name, and then we'll say who weighs, and now we use a float. But I'm going to be particular. I only want to see 5 digits, or I want to see 5 digits, so this will kind of help me to line up my text again by being more consistent. And I only want to see 2 digits of precision past the decimal point. So this many pounds, and is, in this case, I want to see 1 digit of precision past the decimal point and 3 digits total. This many years old. Go ahead and dismiss the warning. Just need to hurry. All right. And okay. And then we need to provide the data, of course. So this will be a dog's eye. Give it the name. Dog's eye again. Give it the weight. And dog's eye. Give it the age. All right. For the sake of time, while I'm here, I'm going to define the last function, which was compare dogs. Const void p1 const void p2. And the way that this method needs to work is that if it's going to work properly in the sorting routine that I'd like to borrow and utilize from the standard library, then it needs to return a negative value if p1 is smaller than p2, a 0 if they're the same size, and a positive value if it's larger. Now, we might be tempted to do something simple like simply subtract p2 from p1, which would give us a negative value if p2 is larger than p1. And do all of the other things we want correctly as well. The problem, though, is that, remember, we're returning ints. So if we're dealing with floating point values that we're trying to subtract, we could end up with a fractional value. Like if, for instance, here we see that if Pepper weighed 1.2 pounds and Buster weighed 1.3 pounds, then the difference between them is less than 1, so that would be truncated to 0, and so compare dogs would always return a 0. So instead, we can use conditionals to get around that problem. We can use an if statement. And so how is this going to work? Well, we need to dereference these pointers in order to make the comparison of the data inside of them. So we first need to cast these void pointers as dog pointers. Okay, but we need to access the data in the struct that this dog pointer is now pointing to. So in other words, we need to further dereference this. So we can wrap this in parens, okay, and say dereference this thing, and then use the dot operator to drill down, or we can save ourselves a little bit of typing, or at least a little bit of moving around, by using the arrow operator here to get at, we're going to use the age in this case, and so that should dereference that value properly. Okay, so again, first we cast p1 as a dog pointer, and then we are now dereferencing that pointer and accessing the age member of it. All right, so we want to see, is this less than p2's age? And if it is, return -1. Okay, I'm going to use my nifty ability to grab a line and paste it, and I'm just going to modify this at each of these lines. And here we'll say if it's equal, then return a 0. I could be very verbose here and say, and if p1's age is greater than, return a -1, or excuse me, return a 1. But the fact is that's the only possibility left, so we can actually get rid of all of that, save some space. Okay, so we've now implemented that function. Let's put these to use. I'm going to switch tabs now to main. So here I got some dogs. Insert. Okay. Then for now, I'm just going to print the dogs. A little over time, a little further than I made this video a little longer than I wanted to already. So we'll just demonstrate these two functions, and then we'll catch the last one in another video, which you can look at when you've got some more time. So we're going to get some dogs, and then we're going to try and print them. This is all assuming that the code we just wrote isn't totally filled with bugs. All right, so we've got some warnings here. Implicitly declaring function printf. Notice this is happening in dog.c. Let's go take care of those warnings. And here's dog.c. And the problem is we needed to include, since we're doing some printing of things, we need to include standard I/O. So dog.c includes dog.h, and so now in dog.h we're including standard I/O. Seems like that's a good place to put it since we know that our print dogs function is going to need it. It would also be valid to put the include standard studio.h in our dog.c file. In fact, you might argue that's a better place, but for now I'm going to leave it right here. There we go. So it did run, or it did compile rather. I'll run sort dogs. Oops, I forgot the number of dogs. I'm just going to do 2 because I'm lazy again. I'm not very creative, so I'm going to use Pepper. Again, we'll say she's 1.2 and weighs 10 pounds. And Buster again, we'll say he's 1 and weighs 15 pounds. Okay, now here we see it's now printing out Pepper, who weighs 10 pounds, is 1.2 years old, which is correct, and Buster, who weighs 15 pounds, is 1.0 years old. All right, so far so good. We'll cut it off there, and in the next video, we'll look at using qsort to actually sort these dogs according to our compare function, and we'll probably call that a pretty good coverage of working with structs and trying to organize our code in C in a way that's somewhat reminiscent of what we would do in C++ with classes. All right, thanks, and we'll catch you later.